Hey, is this thing on?
Hey, Sid, what do you say? What you want to learn today?
I want to know why things happen and how, and I want to know everything now. Oh yeah! How does this thing work? Why does that stuff change? How does that do what it just did? What's up with the sky? You think I could fly? The world's spinning and I want to know why. I've got a lot of questions and big ideas. I'm Sid, the science kid.
Sid, your Chinese friend Bruce is here. Hi, Bruce.
Hi, Sid! Sid, have you done this science project yet?
No, I just don't get it.
It's so hard.
I know. We need to ask someone for help.
Who? Bart
the Smart! And then we go, hi, Joe!
Hey,
Did you finish the homework?
no,
You want to come to Bart's house to finish it?
no,
But don't you want to learn?
whatever. What do you want?
Hiya, Bart's dad. We're looking for Bart.
He's upstairs in his room. Go get him yourself.
Thanks!
Thanks. Hey, Bart.
Hey, Bart!
What's up, Bart?
Hi, guys.
Bart, we need your help with physics.
Physics. I love physics. Well, gee willikers, what do you guys need help with?
Momentum!
Momentum.
There's more momentum with a heavier or faster object than a slower or lighter object. Momentum is a vector quantity in the same direction as velocity. The P is momentum, M is the mass that is multiplied by V, which represents velocity.
I don't get it.
Me neither.
You guys still don't get it? Okay, I'll show you guys a physical example. Let's go!
Go get my skateboard.
It's been like 12 hours. Where are you taking us?
Just 1 minute, let's go. It's over here. Rugby, a perfect example. Momentum is the product of the mass and the velocity of an object and is a vector quantity, which is always in the same direction as velocity. Momentum equals the mass times velocity, which is measured in kilograms seconds. Impulse is the change of momentum of an object. Impulse occurs as a force is applied to an object for a period of time. In this freeze frame, David's kick is the force. The period of time where David's foot is touching the rugby ball is the change in time, which equals the impulse measured in Newton's seconds. Elastic objects collide and then go off separately. The initial momentum of the first object plus the initial momentum of the second object equals to the final momentum of the first object plus the final momentum of the second object. David and Arnold have different amounts of momentum, thus when they collide they fly off in different directions. Inelastic objects stick together when they collide. The initial momentum of the first object plus the initial momentum of the second object equals to the mass of the first object plus the mass of the second object multiplied by a second velocity. David and Arnold have the same amount of momentum, thus when they collide they stick together immobile.
I'm
conservation of momentum state. The momentum of objects in a closed, isolated system is conserved, which doesn't change. The final momentum of the first object plus the final momentum of the second object equals to the initial momentum of the first object plus the initial momentum of the second object, where mv(b2) is momentum of object B after collision. Total momentum after equals into total momentum before. The earlier examples of collisions are all part of the conservation of momentum. David and Sydney represent two objects that collide with different initial momentums. After they collide, they exert the same amount of final momentum coming down.
Thanks for teaching all this momentum stuff, Bart.
Yeah, thanks, Bart. Yeah.
There's more momentum with a heavy
Flying snake!
Wait, really unbalanced.
Okay,